Hello chemistry. This video is for the lab that's called 22.3, and we are going to make the different molecules that are talked about in section 3, particularly page 697. You may want to have your book open while you do this lab. In fact, you probably do. I'm not going to fill it all out here. There's things I will fill in, but other things you need to fill in. And so you want to listen to this lab, and I will actually tell you to put some things in here that may not be clearly asked for. All right, the first one, and we're just going to basically be following our chart in the book here. Our first one is going to be an alcohol. So you can see that the first one it's asked for is 2-butanol. 2-butanol. So again, the but tells us that it's 4, and all tells us it's an alcohol, and 2 tells us where that OH is attached. Just as a reminder to help you with your drawing, here is 1-butanol. 1-butanol, so there it is right there. And you need to draw the structural formula for 2-butanol. Here it is built. Here's 1, 2, 3, 4. So it's but, and it's on the second one. We have the OH group, so that's 2-butanol. Our next one has a name of difluoromethane. So methane meaning that there's only one carbon. Difluoro meaning that there's 2 fluorines. So we have 1 carbon, 2 fluorines. And then it says dichloro, so we have 2 chlorines. Dichloro, difluoromethane. And there it is, so you can draw the structural formula here. And in this chart, it says class, functional group, and general formula. Well, what's that? Well, if you look in your book, you'll see that it lines up exactly with the table. So here's class, functional group, general formula. And so you can put those in here for the appropriate molecule as they're named. Yeah, that's what you need to do. So dichlorofluoromethane, what I would like you to add right here by the name is capital C, capital F, capital C, CFCs, as you'll read in your book about chlorofluorocarbons. So that's a CFC. And another name I would like you to put here is freon. Write down CFCs and freon. Okay, our next one is diethyl ether. So what's an ether? An ether is a molecule that has 2 carbon groups with an oxygen that separates them. So it says diethyl ether. So ether, meaning that that's the oxygen that bonds 2 pieces together. And since it says diethyl, that means there's 2 ethyls together separated by an oxygen. So here's a model. Here's our ethyl, and here's our other ethyl group. Since they're connected by an oxygen, that is an ether. So 1, 2, diethyl ether. All right, and so here's your model that you can build your structural formula out of. This would be R1, this would be R2 for the general formula, and then you can draw this. Notice 2 hydrogens here and 3 on the end. If you need to, pause the video as you go along so that you can see it and draw it. Okay, our next one is aldehyde, formaldehyde, and we're told that our formula is CH2O. So very simple, but yet a little bit tricky. So we have a carbon, CH2, and an O. This is formaldehyde. It's probably one of the more famous molecules. It's used in a lot of things, especially glue. It's bad for you. Try to reduce the amount of use in it. It comes, in carpet, all kinds of things. It used to be used for preserving dissection specimens for biology and so forth, but we've gotten away from it because it's not good for you. So this is the structural formula that you need to draw here. Keep in mind, double bond on the oxygen. You've got to satisfy that octet rule. Formaldehyde. The next one is acetone. and they have told us what the formula is. Notice that it is a ketone. A ketone, so we have a double bonded oxygen to a carbon and then an R group on both sides. Remember, the aldehyde has only an R group on one side and then a hydrogen, so you can think of it like that. But a ketone has the oxygen and an R group on both sides. So that's what a ketone, it helps me just a little bit to remember to think of it as a key, as if it's coming in the middle and trying to open something. Not that that helps a lot, but here's the formula or the structural model for acetone, and you can draw just the carbons, and of course don't forget the oxygen. It just means you don't have to draw the hydrogens for this formula, all right? And the next one we are going to do is an amine. An amine is a nitrogen with R groups around it. So what we decided to do for this one is we're going to write down the structural formula, and we're not going to name this guy. So you don't need to name him. You can skip that step. But here is an amine. Notice the lone pair electrons here. That's what that's about. And you can draw this formula in this space. Put these things in here, and don't forget the chemical formula for this whole row here. All right, we'll go on to the next one. We're going to do propanoic acid. Prop meaning 3. We're going to start with this guy that you might recognize as ethanoic acid, also called acetic acid, also called vinegar. But this would be ethanoic 2. We want to go propanoic. So what we're going to do is we're going to take off one of these hydrogens, and we're going to add onto it another carbon. So here we have some strange looking little doggy-like thing, and this is propanoic acid. 1, 2, 3, propanoic acid. So this is a carboxyl group right here. So that's attached to the R group, and we get propanoic acid. So this is the formula you're going to put in right here. Okay, now we're going to take the next step to the next one, but keep in mind we're going to use this guy to make the last one, butyl acetate. All right, to make butyl acetate, we need that acetic acid part. So you see here the CH3COO? Well, we just used propanoic, so let's turn him back into ethanoic. So here is our CH3COOH. But the H is gone, so we're going to take off this H. And what are we going to put in its place? An R group. In this case, it says butyl. So that means we need to have 4. So we're going to take a 4-carbon chain, 1, 2, 3, 4, and we're going to add it to where that hydrogen was. And there we have butyl acetate. Try to straighten them out a little bit. There we go. Butyl acetate. Notice that it is it has this double bond. Here's a double bond with the oxygen. So this is a ester, carboxylic acid with the hydrogen replaced with an R group. Carboxylic acid and ester. So here it is for you to look at. You might need to pause the video so that you can see it and draw its structural formula down here. Can barely get them in the camera. There we go. You can see the whole molecule there. Don't forget to put all the other things in this, and that concludes our lab. Good job, everybody.